Hello class, this is a video tutorial on mathematical induction. In this video we'll be looking at the second example. So let's get straight to it. So let's prove by mathematical induction a plus a times r plus ar squared plus dot 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 to any term ar to the power of n minus 1 is equal to a times r to the power of n minus 1 all over r minus 1. And for this particular example, they're giving us extra conditions where they're saying that a and r are real. So a is a real number and r is a real number, and r does not equal 1, because if it were, 1 minus 1 is dividing by 0. But the main thing here is that we're only looking at n as the variable. So in this case, we're pretending. So if we were to prove this in a slightly easier example, let's say we had 2 times 2 times 0. That's the first term. 2 times 2 plus 2 times 2 squared plus on and on and on. What this is saying is that if a were 2 and r were 2, is it true that this is the sum of that series? So let's get straight to it. So we're only looking at this in terms of n. So for example, 1, we let n equal the smallest number in the domain. So if this were 2, we let n equal 2. But for this example, the smallest number is 1. So then now we get a plus a r plus, the smallest number is when it's going to be a r 1 minus 1 is equal to, when n is equal to 1, we get a r1 minus 1 over r minus 1. Notice how we're only changing the values of n. This becomes a to the r0, a r minus 1, r minus 1. Well, that just becomes a, because that's r to the power of 0 is 1. And these two cancel, leaving us with a. So you can say that true for n equals 1, left hand side is equal to right hand side. So it's true for the first number. So step 2, for any integer, k is greater than or equal to 1, we assume this to be true. Assume true for n equals k. So then it'll become the original statement, a plus ar squared plus dot 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 a r k minus 1 is equal to a times r to the power of k minus 1 all over r minus 1. Now what we need to work on is to prove n equals k plus 1. So a plus ar squared plus dot 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 a r. Now look at the substitution. It's going to be k plus 1 minus 1. Okay, because we're substituting n equals k where it was originally. So then that will just leave us with k is, so ar times k to the power of equals a times r to the power of k minus 1 all over r minus 1. Now from the from here, we look at the left-hand side. And the left-hand side, we do that similar trick again. AR squared plus dot 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 plus ARK. This is the k plus 1. But the term right before it is AR times k minus 1. It's the term right before it. Well, once again, we assumed this statement to already be true here. So highlighting that once again. So there it is. We're going to substitute it there. So it's going to become ARK minus 1 all over R minus 1 plus ARK. Making this the denominators the same. We get the same R minus 1 for this left-hand term. So that remains the same. But this other term needs the same denominator. So it's going to be ARK R minus 1. From here, we're going to do some expanding. ARK minus A plus, expanding this out, we get AR. Now look very carefully. RK times R becomes R to the power of K plus 1 minus AR to the power of K. So we expanded this very carefully, multiplying it out, all over the same denominator of R minus 1. Cancelling out like terms, these two completely cancel. This leaves us with, I'm going to switch these around as well. It's going to be ARK plus 1 minus A all over R minus 1. I'm going to need some more space for this, so let's draw that line. I'm going to copy this out once again. So continuing from here, we're going to factor out the this ARK plus 1 minus 1 is equal to R minus 1. And that there, if you take a look, since all of this was done from manipulating the left hand side, we've made it look like the right hand side. So this is now equal to the right hand side. And we're done. So we can say, now I'm going to rewrite the same conclusion written in a different way. You can say, by steps 1 and 2, the statement unfortunately, you would need to write this out yourself once again by hand. Thankfully, I've got an iPad, so that statement is true for all n is greater than or equal to 1. And that is the end of the proof by induction. So once again, I hope I gave you an insight into how you might do the mathematical proof by induction. And yeah, hope to see you in the next video where we do another example. Best of luck.